Hello guys, welcome back to John's Workshop, and in this video we're going to dig in a little bit deeper into my Atlas 7B shaper. So if you've not seen the video I put out 2 weeks ago now, where I made my very first part on the machine and did some geometric checks, go back and check that out because that's all context for this video. And during the manufacture of that part I found some squareness issues that I measured actually on the part, not on the machine. And what I want to do now is dig in a bit deeper to try and figure out what might be causing that. So as I said, current measured error from that part, so this is part error not machine error, is, and I'm going to read it off the board so I don't get it wrong, 20 microns over 30 millimeters of squareness error, which equates to roughly 0.8 of a thou over 1.25 inches. And what we're going to do in this video is set some DTIs up, try some different things, some different checks, and see if we can establish what's driving that squareness issue. Is it the vise? Is it flexing the vise? Is it flexing the machine? I don't know, so we're just going to dig in and see if we can narrow it down a little bit. And then if possible, what I want to do is, if I find that it's actually in the vise, the base casting of the vise or the vise jaw itself, or the vise jaws themselves, I will then correct that either by grinding if it's the vise jaws on the surface grinder, or actually machining the base casting of the vise actually in situ on the shaper if we think it's caused by the base casting. So that's what we're going to do. I think that's all the points on the board there, so I will take you to the shaper now and we will start to dig in and see what we find. Okay, so we've got our vise. We've not taken it off the machine since we machined our project. I've put a 1, 2, 3 block in. The vise isn't clamped at the minute. It's on the same height parallels as it was when I did the job, and there is a tendency, because I'm only going to be gripping in the very top, I don't know, 3/8 of an inch, 10 millimeters of the vise, that there's a tendency that I'm going to splay the vise jaws open, which, if there's any flex in this casting here, as there is in all vices, this will deflect by an amount and it will bend and buckle the whole vise base. And because I've got no clamping close to where the fixed jaw is, there is a very good chance that this is going to move by an amount, and that could be causing some of the problem. So I've got 3 DTIs set up. So the first thing I want to do, and I had 2 very good comments from other people and they're absolutely right. You know, in my mind this is absolutely no different from skimming soft jaws in a lathe, where if you're trying to do that without having the jaws in a clamped condition with a ring in, you're wasting your time. And me skimming this back face of the vise here is very similar to that. If I don't measure this in a clamped condition, or I don't skim it in a clamped condition, if I've got deflection, then I'm going to be chasing my tail. So thank you to those who commented. You're absolutely bang on. That's absolutely right. So what I've got is 1 DTI on the fixed jaw at the top. I've got 1 DTI on the moving jaw at the top, and I've also got 1 DTI in the background, which is on the table surface. Now the reason I've got that third one on is because I've got backlash in the lead screw for the table, and if when I'm wrenching up on the vise handle I move any of that backlash, it's going to affect the readings that I see on these 2 DTIs, which will give me a false reading. So that one is as a control, if you like, to make sure that I'm not factoring in any backlash into my readings. So I'll try and reposition the camera from looking at the DTIs from the right hand side. Hopefully I can still get to the vise handle and we will nip them up and see what we get. So hopefully you can see all 3 dials here. You know, focusing in on dial indicators is hard at the best of times. Trying to focus in on 3 simultaneously is quite a challenge with reflection and everything else. So I've tried my best to get them as best in shot as I can. Okay, so I've just slightly tweaked and zeroed out. I really can't see in the viewfinder whether you guys can see clock number 3 back here or not. I'm hoping you can. I won't be able to see that until I put this into edit, but you will certainly be able to see, hopefully it's going to move negative if there is any flex, so it will be coming more into view behind this other DTI. And as I said, this one's our control for backlash. So let us gently tighten up for a start, so see if we don't move anything. So we've got a nip on there now. I'm just trying to really be careful so that I don't move this backlash. Right, that's tight. That's probably about as tight as I was when I did the job. So we've not induced any backlash because we're still reading 0 on this bottom DTI. Our fixed jaw has moved 80 microns minus, so I've got 80 microns of flex in the vise minus, and our moving jaw has gone plus by 50 microns, which means the vise jaw has actually got closer, to the fixed jaw by 50 microns, which you would expect by tightening this up. The jaw is trying to move towards the fixed jaw, so I expected to see a certain amount of movement there. This one's not really telling me a lot. It's this one at the back that's the most important, and I've just nudged it, but that was 80 microns roughly is what that measured. So I've got 80 microns of flex in the vise jaw at the top with a full nip on it. So I'm going to shut the camera off and do a bit of thinking around that, and then I'll think about what we do next in terms of the next set of checks. Okay, we're back. We've done some thinking. We're a couple of days later, and basically what I found after some more sort of yucking and pulling around on this thing was I'd got actually some rock in the table, which I'd not spotted when I checked this out before after rebuild. So we've been round and we've redone all the gibs on both the table up and down and also the cross rail, on the table itself. So I've eliminated all of that movement now. I still think what I measured here was absolute flex in the vise jaw, but what I was finding was when I was tightening up and undoing the vise, because I'd got flex in the table, the whole thing was just rocking like this, and I was getting all kinds of spurious readings on the DTI which pointed me towards something other than the vise, which is what we found. So that's no bad thing. That could have actually affected my squareness. If that was moving around under cut pressure, that could have been part of the squareness issue. I don't think so. I still suspect it's this flex that we've got in the vise. Now this might come as a shock to many people. All vices do this, and it doesn't matter how much you've spent on a vise. If you've bought the top best quality machining vise there is, they still flex. They're just by a lesser amount, and I think it's probably proportionate to the amount of money you spend on the vise. It's how much flex you get. So the cheaper the vise is, the more flex you're going to get. So, and what I'm going to do now is I'm going back to my manufacturing engineering principles, which is where I've spent the last 22 years of my career, which is to guarantee a predictable output from any machine on any operation. It doesn't matter whether that's a £2 million CNC machine, brand new, modern in a factory, or whether it's a 1956 shaper, as in the case of this one. The way you control your outputs to be predictable is by controlling your inputs as much as you can. And one of these inputs that we've got here is me actually tightening the vise up. It's just I'm tightening it up with a handle, or some people whack it with a mallet. Every time you do that, it's going to be different. And if you've got flex in your vise, every time that vise flexes, it's going to flex by a different amount depending on how much pressure you put on the vise. So you will always get variation in your output. So we can control that input by the use of a torque wrench, which we've now got in the workshop. So I'm going to first of all get that set up to a torque that I'm happy with. So I'm going to tighten the vise up as tight as I normally would, and then I'm going to set my torque wrench to that value, and then we're going to come back and we're going to do some checks clamping this vise jaw again. And I'm not, I'm just going to look at the fixed jaw now from now on, clamping up the vise, gripping at the bottom of the vise jaw, gripping in the middle of the vise jaw, and gripping at the top of the vise jaw, and largely map what that deflection looks like with a standardized input from the torque wrench. Okay, so the first thing we're going to do is just check this vise for squareness in a completely unloaded condition. So we've zeroed out there, the vise is, it's not under any load at all, it's free to move, and we're just going to raise the table and we've got absolutely zero. So we know what our relaxed state is of this vise. It's absolutely bang on in a relaxed state. So what I'm going to do now is start loading up the 1, 2, 3 block into the vise at various different heights, and we'll start clamping the vise up and see what we get. Okay, what I've done now is I've added a second clock onto the rail, so that's my control to see whether I've influenced anything with backlash. I won't film that because I won't be able to get them both in shot this time good enough for you to see. So I'll zoom in on this one and we'll load our 1, 2, 3 block into the vise and do our first clamping. Okay, so we're on 0 on the clock. I'm going to put the block right in at the bottom of the vise to start with. We'll just bring that up to a nip. We'll get our torque wrench involved, and this is where I was getting spurious movement before because of the gib on the table not being right. So that's us, no movement at all, and that's that's a good torque. We're talking 47 Newton meters, or I've got meters, 4.8 meter kilograms, which is a strange thing. I don't understand Newton meters either, if I'm being honest, but that's all this torque wrench has got on it. But that's the torque that we've got, 47 Newton meters, and we've got absolutely zero deflection with the 1, 2, 3 block in the bottom of the vise. So I'm going to lift the 1, 2, 3 block up the vise now, which is more likely to induce some bow. Okay, so we put our block now at the top of the vise. This was actually the setup I was using, so we're clamping on the top 10mm or 3/8 of an inch of vise jaw here. So we're still on 0. Vise is loose at the moment. I'm just going to bring it up to a nip. I can already see some movement on that DTI just with a nip on it. So we'll deploy the torque wrench again and see what we get this time. Whoa! So there we go. We've now got 0.12 of a millimeter. So what's that for? That's 5 thou. 5 thou deflection. What I'm now going to do is do the same sweep of the jaw up and down that we did before. Well, as far as I can, I'm going to hit the part, but we're pretty much back to 0 there, and I'm 2/3 of the way down the vise jaw, so you can now see the effect that we've got. Now interestingly, if I set the DTI to the top of the parallel, which is there, and we re-zero, and I'm now going to wind up to the top of the vise jaw, because that's the only bit of the vise jaw that's in contact with the part, therefore the only bit of the vise jaw that's actually influencing the part. With about 30 microns. Now what I've not done is tapped the part down onto the parallels, and the moving jaw will have lifted. You know, and that's why you tap stuff down onto parallels. So I'm just going to try that as a, I don't think it's going to alter anything. What we're measuring there is pure flex in this vice body. So I'm just going to try that as a secondary test. I'll not film that. It's the same test that I've just done, but with this being tapped down in between. If there's anything any different, I'll come back and tell you. Okay, so the plot thickens. I've removed my vice jaw. I've now got my DTI on the back cast surface of the vise, and if I roll down like we did before, we're 0 at the top, we come up to about plus 30 microns maybe in the middle, and then as we go to the bottom, that's a different reading. I don't know if something might have moved there, just double check that. No, we're back to 0, 0 at the top, plus 30 in the middle, minus 10, minus 20, minus 30 at the bottom. So 60 microns of undulation, where the highest point is in the middle of the vice jaw, top to bottom, which probably means my vice jaw is rocking, potentially, not seating flat, but it's only going to rock to the tune of half of that value, so 30 microns. Now, as you saw when we clamped up, I was measuring 0.12 near the top of the vise, so it's only a small fraction of the error, but I'm sure that's part of the error. So what I've done, if I come back down to the top of the vise, we should be back on our 0 point there now. What I've done is I've cocked the tool slide over, so if I just zoom out, I've cocked my tool slide over by an amount that when I now travel down to the bottom of the vise using the tool slide, you'll see it raise up to about 0.1, 0.12 in the centre, and then as we get down towards the bottom, I've aimed for half my total error that I read, which was 0.12, so I'm aiming for about 60 microns at the bottom, which is what we've got there. Let's zoom you back in, you might not be able to see that. So we're 60 at the bottom, plus 60, and we're 0 at the top. So if I now take a cut across this face at that, I'm going to artificially induce a lean in towards the moving jaw at the top of the vise, if you like, so counter to what my squash is and what my movement is in the vise. So by half the error. So I'm not brave enough to go for the full 0.12, I'm going to go for half the error, because like I said, depending on where you grip in the vise depends on how much of that error you're actually going to influence. So I'm trying to take an average here, so that's about as good as I can kind of figure out based on all the checks we've done. So I'm going to get a tool set up and I'll bring you back when we're taking a light skim off this face. Okay, so we're all set up, ready to go. Thank you, Ollie. I told you it wouldn't be long. So, tool kindly donated by Ollie's workshop, and we've got this set up. We've touched on the face, and before I did all of this, I had everything back off, had the vise off, and I've rechecked my table surface for flatness. I've re-trammed my vise in across its length, so I know everything's as good as it possibly can be. I've touched on this face. I've still got my 60 microns taper that I'm going to induce onto this face here, and I've wound myself about 3 thou on cut, something like that, at the top of the vise where we've touched on. So I'm going to crack on in a minute and machine that. Just before we do, I'll show you one out of the Book of Common Sense. Okay, so what do we mean by one out of the book of common sense? Well, this ratchet mechanism on this machine is particularly dodgy. Finding that neutral position in the centre is quite difficult, and you know, I can work around that in normal operation, that's fine. I believe this is a common fault on all Atlas 7Bs, they're all very similar. So I've just been thinking, you know, I'm going to be going down the side face of something now. If this suddenly decides it's going to start engaging through just vibration or whatever as I'm halfway down the cut, we're going to have quite a bit of a problem on our hands at that point. So I was thinking, well, what can I do? Well, it's very obvious thinking about it. I've just stuck my eccentric right in the middle of the shaft. Therefore, even if this does engage, I'm not going to be creating any movement into this ratchet mechanism. Therefore, the table axis shouldn't move anywhere, he says. Right, we'll get a cut on and I'll bring you back. Okay, it's got us a super finish on there. I've just gone down to the bottom and skimmed out this way just to make sure our bottom's nice and square for the jaw to locate on. So I'll just spin you around now. I've set the DTI up and we'll see what we've produced compared to what we had earlier. Okay, we're on 0 at the top and I'm looking for a minus 60 microns at the bottom. So let's see what we've got. Pretty good, about 55 microns, so nearly the 60. And we're back to 0 at the top. So I'm going to reinstall my vice jaw now and we'll repeat the torquing exercise, you know, putting the 3-2-1 block in. 3-2-1, only some people will remember that. In a couple of different places, and we will see if that's made any difference. Okay, so here's the big test. We're going to repeat exactly what we did prior to all of that. So I've put my 1, 2, 3 block back in, torque wrench back on, exactly the same torque as before. Just going to wind in now onto a 0 on the clock, and we will traverse the vice jaw. This is so when I was at the top of the jaw here was where I had my worst error, so as 0.12 of error of actual squash on the vice. So we'll see what we've got now. Strap yourselves in. Oh yes, John's very happy with that. That's pretty much 0. So we've taken that whole 0.12 of error out with the vice clamped, and I know that's repeatable now. Every time I use the torque wrench with the part in the top of the vice like this, I know I'm going to get that same result on that vice jaw, so I can now trust my squareness. So basically I've artificially fudged the vice jaw to account for the amount of rubberized squash that there is in this vice. So what I'm going to do now, I'll not film it unless there's anything to tell. I'll give you the results at the end. I'm just going to drop this down at the other two levels and see how I did before, see what the results are, just in terms of keeping this video at a reasonable length, and we'll bring you back when all that's done. Okay, I couldn't resist showing I have got some movement, as I suspected. So I've got the block right in the bottom of the vise now, tightened it up with the torque wrench again. We're on 0 at the top. As I go down, we've got a bit of movement mirroring the movement we put on, so we're reading about 25-30 microns there now across the full height of the vise jaw out of squareness. I think to have gone from 0.12 of a mil out of square to 0.025 out of square is a lot better. So I'm more than happy with that. That's the worst case scenario. We've gone from the very top to the very bottom, so in the middle will be even less than that value. It'll probably be 10 microns or something like that. So, and I know that's repeatable now. Every time I tighten the vise up, I know what my repeatability is going to be in that vise in terms of squash. So I'm now very happy. The proof of this, of course, is all in the pudding. So what I will be doing on my next job on the shaper is picking something that tests this squareness out properly, and I'm going to be doing some proper squareness checks on the surface plate. I've had a few questions about that, so we'll be demonstrating how you can measure squareness in a home shop using simple tools. So with all of that being done and said, I will bring you back to the board and we'll close this episode out. Well, there we go, guys. I hope you've enjoyed that. And I hope you followed along. There was quite a lot going on in that episode, really, in terms of, I guess, passing on of knowledge, and also in terms of rectifying an issue, in terms of learning about the fact that all vices are made of rubber and they'll all move. So something for anybody who's got their own machine shop with vices on a mill or a shaper or whatever to have a bit of a think about. And probably the most important one there is kind of, you know, my background, manufacturing engineering background, of controlling your inputs to then be able to predict your outputs. Very important. And obviously that's the way my mind works now after years and years of doing that, and that's why we jumped straight to the torque wrench. There was no point undertaking this task until I knew that I could control those inputs, therefore being able to predict my outputs. So I'm now comfortable that if I use the torque wrench every time we tighten the shaper up at that known torque that we've got it set at, I know what I'm going to be getting out of that vise. So then when I measure my parts at the end of the job, I know what kind of outer squareness I should be seeing, and if I'm seeing anything different to that, that's a very, very good indicator that something else is wrong somewhere else on the machine. So it's all about having that knowledge and controlling those inputs to be able to predict your outputs, as I said. So I hope you found that interesting. I'm really pleased that we've done that in a one hit, really, without having to do too many iterations. It's gone quite well. It was all a bit of guesswork in terms of halving the total error and going for the 60 microns, but it's turned out good. So that one was a win. We'll chalk that one up as a win, I think. So thank you all very much for watching. Thank you for subscribing. Thank you to the new subscribers that have come along, and we'll catch you all very soon when we'll be making something else.